Hi guys, today's lesson is going to be in ecosystem interactions. This is our second lesson in our first unit. So again, just like before, you're going to look at your notebook, make sure it's all set up. We'll go over that again in a second. So yesterday when we did the lesson, we learned that your teacher likes to use incredibly cheesy memes and video clips to reinforce concepts. And today will be no different. So your notebook, if you haven't gone to Schoology, should look like this. On the left-hand side, you have 12 terms that we're going to go over for this lesson. So you can pause the video now and copy it from this screen, or you can go back to Schoology and click on that link where we always set up our notebooks. On the right-hand page, or page 5, is where you're going to do your reflection at the end. Make sure that your reflection is 5 complete thoughts, complete sentences. You can't just write 5 random words from the lesson. So 5 complete thoughts about the lesson. If you got little bitty hands, you can trace a big person's hand. If everybody in your family has monkey paws, make it up. I don't care. So just make sure you have that hand drawn over there for your 5. Give me 5 reflection. So today we're looking at the top 12 ways organisms interact. After this lesson, you should understand that organisms and populations in an ecosystem depend on and may compete for biotic factors such as food and abiotic factors such as quantity of light, water, range of temperatures, and soil composition. So number 12, interspecific competition. That word should be familiar from the previous lesson. It is a form of competition between different species of the same ecological area, meaning they're living in the same ecosystem. And enter the competition. Number 11, intraspecific competition. It is an interaction in population ecology whereby members of the same species compete for limited resources.
Having found one who seems to be promising, a male stays close to her side to try and ensure that he and no other male mates with her. The most dominant male is likely to be the one to father most of the next generation, and that is something worth fighting for. Judo is also fight, but it's just play boxing, a way of learning skills that will be important in later life. But it's not always a fair fight. Fortunately, this little one still has mother to see off the neighbourhood bully.
Number 10 is mutualism. Mutualism is a symbiotic relationship between organisms in which both species benefit from the relationship.
Tree falls in the Costa Rican rainforest, a gap of sunlight is formed in the canopy. New life competes for this light, like this vine racing this sapling upward. But there's one tree that never has any competition, thanks to an incredible symbiotic relationship it shares with an ant. The swollen thorn acacia and its namesake, the acacia ant, have developed harmonious roles in each other's lives. The ant's role is as protector. If any of those vines try to steal the acacia's light, the ant's security guards go to work. A few good chomps on the vine stems, and it's lights out for the vine. The ants don't stop there. This relatively huge grasshopper may think it's going to take a few bites out of the non-poisonous acacia, but the ants take a few bites out of it instead. And they throw in a few stings for good measure. In exchange for all this protection, the tree takes on the provider role. It gives the insect everything it needs in terms of food and shelter. These little nodules, or nectaries, secrete a sweet nectar for the adult ants to eat. And these brownish pods at the end of some leaves are the perfect, nutrient-packed food for the ants' developing young, called larvae. The acacia ant larvae live down hollowed-out thorns at the base of the acacia leaves. Some will eventually grow into adults with wings and will fly off to replicate this evolutionary masterpiece in a new acacia.
Number 9, commensalism. Commensalism is another symbiotic relationship between two organisms where one member of the relationship benefits, but the other isn't hurt or harmed.
Here in nature, plants and animals interact all the time, but it can be a lot more complicated than just one thing eating another. These relationships between two different organisms can be examples of what we call symbiosis. Symbiosis can be defined as any kind of a close, long-term biological interaction between two different organisms. These interactions can be mutualistic, commensalistic, or parasitic. Today, we're going to explore the incredible world of commensalism. This big web is the home of a female spider of the genus Nephila. In her web are BB-sized spiders called dewdrop spiders, gleaming silver droplets sprinkled about. Nephila could care less. She doesn't seem to notice them. The prey Nephila wants are the larger things that fly or jump into her web. The dewdrop, on the other hand, is there to grab the smaller prey that Nephila discards. It also likes to drink the drops of dew that collect on Nephila's silken lines. The two species of spiders are feeding at the same table, you might say. And that describes commensalism. Commensalism is a symbiosis in which members of one species gain benefits, while the other species is neither benefited nor harmed. In Costa Rica, army ants roam freely over the floor of the jungle, ravaging everything in their paths. Other insects either flee or are carried off for dinner at a later time. This is an opportunity that can't be passed up. Numerous species of birds, such as the wood creeper, have become specialists at following army ants just to catch the insects stirred up in the chaos. Once again, commensalism and symbiosis in action, building complexity and diversity into our world. The world is full of interesting examples of symbiosis. If you thought commensalism was fascinating, check out our other videos on mutualism and parasitism.
Number 8, parasitism. Parasitism is a symbiotic relationship between species where one organism, the parasite, lives on or in another organism, the host, causing it harm and possibly death. The parasite becomes structurally adapted to the host's way of life.
Here in the southeastern United States, these besieged plants have actually sent up a chemical mist, an SOS to these black wasps. Why? Because black wasps are known as aphid killers, and some aphids are busily sucking the life out of these plants. Now, despite its nickname, this wasp isn't here merely to kill the aphids. No, that would be too easy. Like a character in a James Bond movie, the wasp has a more exquisite punishment for the aphid. With a clinical precision, the wasp injects a single egg into each aphid's body. This means a slow death for the aphid, as the wasp egg grows inside it. Each wasp can plant eggs in 200 aphids. The aphids send out their own chemical alarm systems, and the colony panics. But it's too late. The wasp has done its work. Hasta la vista, baby. And we mean baby. The aphids face a gruesome death. The ravenous wasp larva will eat the aphid alive from the inside out. The aphid's body becomes the incubator for the young of its predator. A new generation of assassins will soon emerge, littering these killing fields with corpses. Okay, now here's the money shot. The young wasp emerging to seek out more aphids to begin this cycle all over again. The wasp, with its exquisitely deathly plan, and yet, just doing what nature's programmed it to do.
Number 7 is niche. Sometimes you'll see it called ecological niche. It's simply an organism's role in its environment.
How do so many animals coexist without eating each other's food? The answer is simple. Every species has a different, specialized survival strategy. Every species occupies its very own ecological niche. By doing this, there is enough food for everyone. Pelicans prefer to fish in cloudy, muddy waters. They work as a team. Swimming in a big semicircle, they herd the catfish into shallow water close to the shore. They flap their wings to stop the catfish escaping. Over and over, the birds dive into the water, scooping the fish into their bills. The large bill is designed to catch large fish. The black heron uses a unique hunting technique. It only has short legs, so it is confined to the shallow waters, a zone where the bigger herons don't usually hunt. It takes short, sharp steps to scare the fish. Then it spreads its wings out like an umbrella. The fish seek protection in the darker areas under the wings, and then it's good night, sweet fish. Now omnivores like the Nile monitor have moved in. The monitor forms a semicircle with its body to trap its prey and then moves toward the shore. In shallow water, it's easier to grab the fish with its mouth. This is a very successful method in waterholes like this one.
Number 6, predator-prey relationships. In a predator-prey relationship, one species is feeding on the other species. The prey species is the animal being fed on, and the predator is the animal being fed, or the hunter.
Must continuously evolve to evade their predators. Some use camouflage to hide. Blue morpho butterflies try to scare attackers by flashing brightly colored wings. Other animals become poisonous and advertise their toxicity with bright colors. The predators must also evolve to keep up if they are to successfully catch their prey. Predators with venom spend less energy chasing their dinner. Others, like this jaguar, have evolved to be big and strong so they can grab and hold their prey. And some, like this praying mantis, use camouflage so their prey doesn't see them until it's too late. This all builds to turn a tropical rainforest into a whirlpool of biodiversity.
Number 5, autotrophs or producers. An organism that can produce its own food using light, water, carbon dioxide, or other chemicals is called an autotroph. We usually call these plants, algae, and certain types of bacteria.
I know! We can act like plants! Photosynthesis! Photosynthesis!
Want to go to the park?
Number 4, heterotrophs or consumers. Organisms that cannot produce their own food and instead take nutrition from other sources are called consumers.
Get in my belly!
Number 3, carnivores. Animals that get their food from killing and eating other animals.
For you, it's a
Okay.
battle between octopus and crab, and who do you think would win?
Well, I think octopus.
Really?
They're bright. They're very intelligent creatures.
Well, you could be right.
Of course.
You would be, wouldn't you? A spectacular scene, really, captured this video in Western Australia. A spectator there. You can see the crab minding its own business when an octopus jumps out of the water and onto a rock. We don't think this has ever been captured before. It then pulls the crab back underwater, and it's not every day that you see an octopus hunting on land, is it, Issa? Scientists saying, though, it can happen near any shore.
Very strong, isn't he? It was tiny octopus too.
And you won the argument, which is quite annoying, so I thought the crab. I'm Max Foster in London.
Herbivores are animals that feed solely on plant and plant material.
What's this stuff that looks like sand?
It's quinoa.
Nope, I don't eat foods that sound like karate words.
Omnivores is number 1. Most humans are omnivores. Omnivores have the ability to eat and survive on both plant and animal matter.
What's this? A piece of toast? A pretzel stick? Popcorn? What blockhead cooked all this? Hello? Hello?
Alright guys, that is the last one for today. Make sure you filled in all your notes. You've done your reflection. If you do a really good reflection and you're really proud of the one you gave me or you prepared, email it to me. Take a picture, shoot it to me in an email. Maybe I'll feature you in the next video. If you have any questions or concerns, please make sure that you email me or send me a remind chat. Have a good one.